Now we have seen all the basic parts of DC machine. Now we are going to handle the question related to GATE examinations. Just like this question is related to GATE 2023. Given that a separately excited DC motor rated 400 volt, 15 ampere, 1500 RPM drives a constant torque load at rated speed, operating from 400 volt DC supply drawing rated current, and the resistance is to 1.2, and the voltage drops by 10% with the field until and resultant speed of the motor of the RPM is what. So if the information is mode is given in the question, so that the answer will be easier for us. Why? We are going to see that in the following slide. The slide given that B1 is equal to 400 volts is given. Armature current is 15 ampere, N1 is 1500 RPM rated speed. RA is also given. Armature resistance is 1.2 ohm. Supply voltage drop by 10%. So the EMF equation is E is equal to Kn phi n. So E is equal to Kn phi n means E is equal to induced EMF and the back EMF, and the K is the machine constant, N is the speed in RPM, and the phi is the flux per pole. So E is equal to V minus IaRa for motor, and for generator E is equal to V plus IaRa for generator. So in this V1 is given and IaRa are also given. So you can see that V1 is given and Ia and Ra are also given. So we can find with the help of V1 and IaRa, EB1 is equal to 382 volt, and given that supply voltage are drops by 10%. So drops by means less. So 0.9. 100 minus 10% is 90%, and 90% is 0.9. So 0.9 into 400 is equal to 360 volt. So, and in the question also given that torque is constant. So armature current is also constant. Armature current is given that 15 ampere. So Ia2 is also 15 ampere. So now the new EMF, what is new EMF? EB2 is a new EMF, and EB2 is equal to V minus Ia2 RA. V2 minus Ia2. So V2 is, we are calculating earlier that V2 is equal to 360 volt. So 360 volt, Ia2 is 15 ampere, and RA is given 1.2. So 1.2. So EB2 is equal to 342 volt. And in the equation, you can see in the earlier E is equal to Kn phi n. So with the help of this equation, E is directly proportional to N. So N2 E N2 by N1 is equal to EB2 by EB1, because E is directly proportional to N means rated speed. So N2 we have to find that, and N1 is given 1500 RPM. N1 is given at 1500 RPM, and EB2 we can just find that 342 volt, and EB1 is 382 volt. So with the help of all the things are mentioned, and we have to find that N2 value. So N2 is equal to 1500 into 342 by 382. So N2, if you calculate, then the result is 100 1000, sorry, 1343 RPM is the answer of this question. Now move to the next question. This question is asked by GATE in GATE Electrical 2022. Given that voltage is 280 volt, and say this is a separately excited DC motor. So we have to use E is equal to V minus IARA because motor is there. If the motor is there, then remember that V minus IARA. And if the generator is given, then V plus IARA. And armature resistance is also given. Constant field drives and given that torque is directly proportional to speed. Means T is directly proportional to N. At 1000 RPM draws at 30 ampere. If 10 ohm additional resistance is added in series with the armature, find the new speed in RPM. So don't see the answer firstly. First you can solve the question of in this question. Then you have to see the answer of this solution. So in this given that V is equal to 280 volt, this is the given parameter. R external is equal to 10 ohm, and IA1 is equal to 30 ampere, and torque is directly proportional to N, rated speed. So we have initial back EMF is equal to V minus IA1 R1. We have earlier said that V is 280 volt is there. IA1 is 30 ampere and RA is equal to 1 ohm. So 250 volt EV1 means the induced EMF EV1 is equal to 250 volt. With the help of, and one of the formula are also known very popular, that torque T is equal to Ka phi Ia, where K is the constant and phi is the flux and Ia is the armature current. So in these, torque is directly proportional to Ia, and in the given question, torque is directly proportional to N. So torque is also proportional to N and torque is also proportional to armature current. So armature current is also proportional to speed. You understand that because torque is directly proportional to N and torque is directly proportional to Ia, that's why Ia is directly proportional to N. So Ia2 by Ia1 is equal to N2 by N1. With the help of these proportionality, Ia2 is equal to 30 into N2 by 1000. So in this given question, extra resistance are also there. So that's why R total is equal to 1 plus 10 is equal to 11 ohm. Okay. And how can I find EV2? B minus IA2 into R total. R total is 11 ohm and IA2 we are not known that IA what is the value of IA2. So we can find the value of IA2 with the help of E is equal to is directly proportional to N. Why E is directly proportional to N? Think that in the previous solution we have mentioned that E is equal to Ka or Kn phi n. So E is directly proportional to N. That's why EV2 by EV1 is equal to N2 by N1. So 280 volt EV2, 280 volt minus 11 Ia2, and EV1 is 250 volt. EV1 is 250 volt and N2 by 1000, and we can earlier find that Ia2 is equal to 30 into N2 by 1000. So we can substitute this value in equation in this equation. So we can find that N2 is equal to 483 rpm. If we solve this equation, then the solution is N2 is equal to 483 rpm is the solution of this question. Find the new speed. So N2 is the new speed and N2 is value is 483 rpm. Now move to the next question, guys. These questions are asked by IIT in GATE 2018. A separately excited DC motor with armature resistance of 0.05 ohm, voltage is given, uh, speed is given, and zero speed means n is equal to 0, and negative magnetic mechanical losses. Find the no load speed in radian per second when armature voltage is increased to 150 volt. Means V2 is increased to 150 volt from 100 to 150 volt. So all these given statement are written there. Just like V1 is 100 volt, torque speed, torque at zero speed 500 nanometer, and mechanical losses are neglected. V2 is equal to itna, V2 is equal to 150 volt. So we are earlier told that torque is equal to Ka phi Ia. So torque is directly proportional to armature current, and at zero speed EV is equal to 0. Why? Because E is equal to Kn phi n. Phi is the flux and is the speed. So in this given question, speed is mentioned at 0. So E is equal to Kn phi n. N is directly proportional to Eb. So Eb is equal to 0. And so armature current is equal to Ia1 is equal to V1 by Ra. So normal Ohm's law, if you apply the Ohm's law, V is equal to IaRa. So Ia1 is equal to V1 by Ra. So Ia1 is equal to 2000 ampere. And torque constant, torque is equal to K phi Ia, this formula. And if you apply this formula in this equation, in this, then we have to find that K phi is equal to 500. Torque is given at 500 and Ia is also given that I1 is also given at 2000 ampere. So K5 is equal to 0.25. No load condition. In low load condition, EB is equal to V2 because E is equal to V minus IA RA. RA is equal to 0 and the armature current is also 0. So E is equal to V, and E is equal to V is equal to 150 volt. So 150 volt is V2. So and E is equal to Ka phi omega m. These are all the also the formula of induced EMF. Two formula of induced EMF. E is equal to K n phi n and E is equal to Ka phi omega m. Omega m is the speed of this DC machine. So EB is 150 volt and Ka phi, let's find it. Ka phi is equal to 0.25. I said Ka phi. You can think like that. Ka, Kb, Kc, anything. K is a constant value. Okay. So 150 volt is equal to 0.25 into omega. So omega is equal to 150 divided by 0.25 is equal to 600 radian per second. So the answer of this the question is 600 radian per second is the answer of this question. We can move to the next slide, guys. These questions are asked by IIT GATE 2023. Sorry, 2017. 220 volt voltage are given. We have to find that the supply current, rated terminal voltage at rated speed, electromagnetic torque is given, and the supply current. If in the question torque is given, then we should apply the torque is equal to K phi Ia and torque is equal to P by omega. Okay. So in this given question, voltage is given, rated power is given, and is also given, and armature resistance is given, and torque, electromagnetic torque is given. Electromagnetic torque is 70 nanometer. So convert this speed into radian per second. How can we convert this speed in radian per second? Omega is equal to 2 pi nr by 60. 2 pi n by 60. So 2 pi n is value is given 900 and n and 6 divided by 60. So 94.25, approximately 94.25 radian per second is the omega value. So and with the help of this formula, P PEM is equal to TE into omega. These are the electromagnetic power developed formula. So torque is given and omega is given. So PEM is equal to 6598 watt. Now we have to find that supply current. So P is equal to EB into IA is also the formula of in DC machine. So B is equal to EB plus IARA. In this, they are the DC motor. So E is equal to B minus IARA and B is equal to E plus IRA. These are the normal equation. Okay. So E is equal to B minus IRA. If you put this value in these equations, in this P is equal to EB into IA, so B minus IARA into IA is equal to 6598 is the power. In this, they are given that power 6598. Okay. So with the help of these, we have to find that IA value, means armature current value. So armature current value after solving this complex equation. Why I am saying the complex equation? Because we have to square them with 11,000 square and 4 into 3,29,900. Okay, and then we have to calculate. So this is a lengthy process, and then you have to find that what is the value of IA. So IA is 30 ampere. So 30 ampere is the answer of this question. Find the supply current. The question said that what is the supply current of this question and the armature current of this question. We can also say that armature current. So thank you so much, guys. If this video helps you to solve the GATE PYQ, then please subscribe this channels and support me, guys. I'm a new person and try to teach you in a better way. Day by day, I am improving my teaching styles.